Hi everyone. In this class, we are going to discuss about series RC circuit is excited by an AC supply. Series RC circuit is excited by an AC supply. Series RC circuit is excited by an AC supply. Yeah. First, draw the circuit. RC series circuit is connected to AC supply. Resistor R is connected to capacitor in series with capacitor, and this series combination is connected to AC source. AC source. This is R and C. The supply voltage V of T is nothing but instantaneous applied voltage. Remember, small v means instantaneous value. It is Vm sine omega t. When alternating voltage is applied to the combination of series RC, then alternating current is flowing I of t. When alternating current is flowing through resistor and capacitor, there is a voltage drop. Voltage drop across resistor we are calling as VR, and the voltage drop across capacitor we are calling as VC. Here V of t is nothing but instantaneous value, and suppose if we are considering small capital V, and this is the RMS value. RMS value. Yeah. Let V of t is nothing but instantaneous applied voltage and our capital V is equal to RMS value of applied voltage. RMS value of applied voltage. Yes. Capital V is equal to RMS value of applied voltage. And capital VR. Remember, whenever we are considering capital letters, these are RMS values. Remember, VR is nothing but voltage drop across resistor, that is equal to I into R. Okay. VR is equal to I into R. Or we can write pure resistor voltage and current are in phase. Then we are writing VR at an angle 0. Then VC is nothing but voltage drop across capacitor. Voltage drop across voltage drop across capacitor, that is equal to I into minus jXC, where minus jXC is nothing but impedance of the capacitance. Impedance of the capacitance. Then we can write VC at an angle minus 90 degrees. Minus J indicates the minus 90 degrees. Okay, and these are the from the circuit. Next, according to in previous lecture we are discussing, first we are going to draw the phasor diagram and vector voltage triangle. Phasor diagram and voltage triangle. First we need to draw the phasor diagram. Phasor diagram. Yeah, we know it is series circuit. First we are taking current as a reference phasor, right? Current as a reference phasor. Then current is drawing in x-axis. Current as a reference phasor with phase angle 0. Then we need to draw voltage drop across resistor, that is in phase with current I, because in pure resistor voltage and current are in phase. We are at an angle 0. Then we need to draw the voltage drop across capacitance VC. Okay, now VC at an angle minus 90 means capacitance. In pure capacitance, voltage is lagging current by 90 degrees. Voltage is lagging current by 90 degrees. Therefore, we are trying voltage VC. VC is lagging current by 90 degrees. Okay. Then when we are adding VR plus VC, which gives total applied voltage, RMS voltage. VR plus VC is equal to total applied voltage. Then join these two vectorically, then we are getting V, total applied voltage V. This is the angle minus phi. This is our applied voltage. This is the phasor diagram of series RC circuit. Phasor diagram of series RC circuit. Phasor diagram of series RC circuit. Then next, draw the voltage triangle. Next, draw the voltage triangle. Voltage triangle. Yeah. How we are drawing voltage triangle? Voltage triangle is drawing from the phasor diagram. And without considering current phasor, draw as it is, which gives voltage triangle. Okay. VR, this is VC, and this is V. Angle is minus phi. We know VR is equal to IR. VR is equal to IR, and VC is equal to IXC, and V is equal to IZ. V is equal to IZ. Next, we need to calculate impedance of the circuit, and we need to draw the impedance triangle. Is this clear? Next, calculate impedance. Impedance Z. How to calculate impedance? Yeah, by applying simple KVL to the circuit. By applying KVL to the circuit or from the voltage triangle, anyone can take. By applying by applying KVL. By applying KVL, we can write total applied voltage is equal to voltage drop across resistance plus voltage drop across capacitance. And then we know total applied voltage is nothing but V is equal to IZ. Then VR is nothing but IR. VC is nothing but minus JIXC. From this, take I common or minus JXC. IZ is equal to I into R minus JXC. R minus JXC. For I gets cancelled. I gets cancelled. Then Z is equal to R minus JXC. R minus JXC. This is the impedance of series RC circuit. Remember, this formula is very important and measured in ohms. Impedance of series RC circuit. Impedance of series RC circuit. Z is equal to R minus JXC. Next, we need to draw the impedance triangle. Next, we need to draw the impedance triangle. Impedance triangle. Impedance triangle. How we are getting impedance triangle? Divide, divide voltage triangle. Divide voltage triangle. Triangle by current. I. When we are dividing voltage triangle by current I gets cancelled. Here Z is there and here XC, here R. Okay, now that is the impedance triangle. This is the resistance. This is the reactance. And this is Z impedance. Angle is minus 5. This is the impedance triangle. From the impedance triangle, you can calculate power factor. Write the formula for power factor. That is cos phi is equal to R by Z. And next, we need to write the formula for phase angle. Phase angle. Phi is equal to, I already told, phase angle is nothing but imaginary part. Imaginary part by real part. What is the imaginary part? Imaginary part is nothing but XC. And what is the real part? Real part is nothing but R. This is tan inverse of XC by R. Phi is equal to tan inverse of XC by R. You need to remember these formulas also. Cos phi is equal to, power factor is nothing but phi Z, and phase angle phi is equal to tan inverse of XC by R. Okay, suppose actually phase angle tan inverse is nothing but imaginary part we are getting negative, and here we are taking phi as a negative. No need to write a negative sign here. Okay, phi is equal to tan inverse of minus XC by R if we are writing phi only. Okay, here already we are taking minus phi. No need to write minus X. Okay, and this is impedance of the circuit. Actually, then next we need to calculate current. Next we need to calculate current. Current I of t, current I of t. We know that what is the formula for currents? What is the formula for current? Current I of t is equal to V by Z. From this I am writing V at an angle 0 by mod Z at an angle. Phi is negative, right? Here phi is negative. That's why I am taking mod Z at an angle phi. Mod Z is the magnitude of the impedance and phi is the phase angle of the circuit or phase angle of impedance. Phase angle of series RC circuit. Phase angle of series RC circuit. From this I am writing V by mod Z, and this denominator angle goes to numerator, and this is phi minus of minus phi. Therefore I is equal to V by mod Z at an angle plus phi. It is clear from the current equation. For RC series circuit, current is leading. Current is leading voltage by some angle phi. So here, from the phasor diagram, current is leading voltage, applied voltage by some angle phi. Is it clear? Current is leading. This is the voltage and this is the current. Means current is leading the voltage an angle phi. Okay, and therefore I of t is equal to Im sine of omega t plus phi. Omega t plus phi. This is the current equation of series RC circuit. Current equation of series RC circuit. Remember this formula also. Current equation of series RC circuit. Is it clear? First, we are drawing phasor diagram, then voltage triangle, then we need to calculate the impedance of series RC circuit. Then we are drawing impedance triangle. From impedance triangle, we are writing formula for power factor and phase angle. And phase angle is nothing but tan inverse of XC by R. And next we need to calculate current. I is equal to V by Z. V is nothing but this is the voltage. V of t is equal to Vm sin omega t, means there is no phase angle. That's why I am taking angle is 0. V at an angle is 0 and Z at an angle minus phi. And this is finally V by Z at an angle plus phi. And this is the current equation. From the impedance equation, where where Xc is equal to capacitive reactance. Capacitive reactance. I think everyone knows X is equal to capacitive reactance. What is the formula for capacitive reactance? Xc is equal to 1 by omega c. You need to remember this formula also. Xc is equal to 1 by omega c. And this is also measured in ohms. Remember the units also. Is it clear? Yeah. What is the next step? Next step, we need to draw the waveforms. Then next, waveforms. Draw the waveforms, right? Both voltage and current equations first. Then it is easy to draw the waveforms. First voltage equation, V of t is equal to Vm sine of omega t plus 0, and current equation I of t is equal to Im sine of omega t plus phi. Omega t plus phi. Is clear? Yeah. Then right. First draw the voltage, then draw the current waveform. First, I am drawing the voltage. This is my V of t. This is my V of t. Next, draw the current phase, current waveform. Next, draw the current wave. Current is leading the voltage. Current is leading the voltage. Leading the voltage by some angle phi. This is the angle phi. Okay. This is my current equation. Current waveform I have to. Okay. Suppose if you want to calculate phase difference between voltage and current, then calculate the phase difference. Phase difference. Phase difference is equal to 0 minus of minus 5. This point is minus 5, which gives 5. Means plus 5 means it is leading. Plus 5 means it is leading phase angle. Is this clear? Yeah. Next, we are going to find instantaneous power. Same instantaneous power, same as RL series. Instantaneous power. Instantaneous power. P is equal to V is equal to V into I, and V is nothing but Vm sine omega t. I is nothing but Im sine of omega t plus phi. Omega t plus phi. Vm Im sine omega t sine of omega t plus phi. Before we are writing Vm Im 1 by 2 cos of A minus B means omega t minus omega t plus phi. Next, cos of A plus B. A means omega t plus omega t plus phi. Then Vm Im 1 by 2, and omega t gets cancelled. Then it is cos of minus phi minus of cos of 2 omega t plus phi. Vm Im by 2 cos phi minus Vm Im by 2 cos of 2 omega t plus phi. Then this is the instantaneous power. Next, calculate average power. Average power. Then average power, we know that when we are calculating average of total complete cycle, it gives the zero average power. Therefore, the average power P is equal to average of this part and average of this part. And average of this part will give the 0. Therefore, Vm Im by 2 cos phi is there. Vm Im by 2 cos phi. I'm writing Vm by root 2 and Im by root 2 cos phi. Therefore, it is Vi cos phi. We know that Vi, this is the average power observed by the circuit. Average power observed by series circuit. P average is equal to Vi cos phi. We know that Vi cos phi is nothing but real power. Vi cos phi is nothing but real power watts. Okay, now, and it is also, and yeah, this is the average power. Then one small topic is there. Actually, power triangle. In RL series, I am not covered this topic, and same in that also power triangle. Power triangle. Yeah, just previous. And how we are getting this impedance triangle? We are dividing this voltage triangle by current, then we are getting impedance triangle. Then we are getting the triangle called impedance triangle. If you want to get power triangle, we are multiply this voltage triangle by current. Then we are getting power triangle. Yeah, see. Okay. Multiply voltage triangle by current I. Multiply voltage triangle by current I. Then we are getting power triangle. Yeah. See here, when we are multiplying with current, it becomes I square R, and this is I square XC, and it is I square Z. The angle is minus 5. Angle is minus 5. Okay. From the power triangle, also we are writing the formula for power factor and phase angle. Okay, now power factor cos phi is equal to, it is R by Z only, because I square R by I square Z will give R by Z. Then phase angle phi is equal to tan inverse of XC by R. Okay, now. And I square R, generally we are considering as a active power. P is equal to I square R, and I square XC we are considering reactive power Q, and I square Z we are considering apparent power S. Therefore, P is equal to I square R Vi cos phi. We are using any one of this formula when we are doing the problems. I square Xc or Vi sin phi, and S is equal to I square Z or V into I. V into I. And what are the units? What are the units for active power? It is measured in watts. What are the units for reactive power? Volt, ampere, reactive. And what is the units for apparent power? It is volt, Vi. Okay, volt, ampere. Is this clear? Va. This is volt, ampere. Va. Is this clear? is volt ampere. Yeah, this is about series RC circuit connected to AC supply. Is this clear, everyone? Thank you.